Protein interactions with the ligand can be monitored throughout the simulation in the PL Contacts or Protein Ligand Contacts tab. In the above plot, we see a summary of these interactions, but we can choose to include one type of contact at a time to reveal even more information about that contact. So let's look at these in detail, starting with hydrogen bonds. But first, let's note that we can keep our cursor over any of these checkboxes to see a tooltip with the definitions. Okay, here we have 4 categories of hydrogen bonds, including the backbone donor or acceptor and side chain donor or acceptor hydrogen bonds. For serine 27, we can see that it is interacting with the ligand over the course of the 50 nanoseconds by making 0.942 contacts. Now these contacts are normalized, so you can also say that it's interacting with the ligand about 94.2% of the time. For tyrosine 43, we can say that it's interacting with the ligand 100% of the time. Now for asparagine 49, we can see that it's making a hydrogen bond with the ligand more than 1 or more than 100% of the time. Now it's able to be more than 100% because asparagine 49 is making 2 types of hydrogen bonds during this period. It's acting as a backbone donor about 84.7% of the time, while also acting as a side chain donor about 23.9% of the time. Here we can see the hydrophobic interactions. So for example, tryptophan 108 exhibits hydrophobic interactions about 30.7% of the time, but no pi-pi stacking or pi-cation interactions were detected in this system. Only one ionic interaction was established by arginine 84, but this was extremely brief at only 0.1% of the time. Now here we can see the interactions to the ligand that were bridged by a water molecule and broken down as either donor or acceptor. Here we can see that tyrosine 54 and tryptophan 79 were able to interact with the ligand about 13 to 14% of the time, even though the residues themselves did not form any direct hydrogen bonding interactions with the ligand. Okay, now if we include all contacts again, we just see the summary of the results without the individual breakdown. Now below this plot we have a timeline of the contacts where you can see the total number of contacts being made to the ligand by the protein over the 50 nanosecond period. While below that we can see when the contacts were being made, referring to the time on the x-axis, which residues were making them based on the y-axis, and how many contacts were being made based on the color intensity. So for example here, arginine 84 seemed to make most of its contacts with the ligand between the 17.5 to 30 nanosecond period, and those contacts were mostly direct hydrogen bonds to the ligand, with some mediated by water. Now asparagine 128 has a similar number of contact counts as arginine 84, but notice in the timeline that it has a lighter orange color, indicating that arginine 84, with its darker orange color, was able to make multiple contacts at a given time. Now the last thing to note on this panel is that you can select the trajectory range. So for example, perhaps you're only interested in the last 20 nanoseconds of the simulation, or during the period where the protein RMSD values stabilize.